Hi everyone. We have the radical function f of x equals root x squared minus 4, and we are asked to find the range of values of x for which this relation will not qualify for a function. Okay, so the relation again, f of x is equal to root x squared minus 4. Okay, so we need to get the domain of this relation, and then we will see those values of x that will render this relation a function, and those values of x that will render it not qualified for a function. Okay, we have this radical, the root sign here. We know that the root of negative numbers don't exist. Root of negative numbers don't exist. So we have to simplify those range of values of x that will render the expression x squared minus 4 negative, and then we exclude them. That will now give us the set of values of x for which this expression will be a function. Okay, so for this therefore to be qualified to be a function, x squared minus 4 must be greater than or equal to 0, because we can get the root of 0, which is 0, and we can get the root of positive values. So this expression here can either be 0 or positive. So when does that happen? It means that x squared minus 4 must be either greater than or equal to 0. Okay, for this root function to be possible, it can either be 0 or greater than 0. Now, the left-hand side here is a difference of squares. 4 can be written as 2 squared. So we know from the identity of difference of squares that this can be written as x minus 2, x plus 2, greater than or equal to 0. From here, we have two critical points. The points, when we set this to 0, the point is 2. And when we set the other one also to 0, the point is negative 2. Now we place those points on the number line in their rightful position. Negative 2 is to the left, positive 2 is to the right. We have 1, 2, 3 zones to test. We take a value from this zone. An example could be negative 3, and we put it there. We're interested only in the sign, knowing that greater than 0 simply means positive. On the number line, we remember 0 is always in the middle. Greater than 0 means positive values. Less than 0 means negative values. So greater than 0, positive. So whatever value we slot in here and we evaluate, if the sign ends up being positive, then we know that that zone will give us a valid solution. So let's start with this zone. Take a value from the left of negative 2. Example is negative 3. We'll put here. Negative 3 minus 2 is going to be negative. We're interested only in the signs. Negative into, we'll put negative 3 here. Negative 3 plus 2, negative. Negative multiplied to negative, positive. Take a value in this zone. For example, 0. 0 is found in this zone. We'll put 0 here, we'll have negative. We'll put 0 here, we'll have positive. Negative multiplied to positive, negative. We will take a value here in this zone. For example, 3. We will put 3 there. 3 minus 2 is positive. 3 plus 2 is positive. Positive multiplied to positive, positive. So we have positive here, negative, and positive here. But our inequality says our solution should be in the positive zone. Greater than 0 means positive. So our solution lies here and or here. So we'll say solution will be all real values such that x is either less than or equal to negative 2 or x is greater than or equal to 2. This is our solution set. These are the values of x that will make this relation a function. But remember, the question is saying we should get those values that will make that relation not to qualify to be a function. Okay, so these values, again, on the number line, we can see clearly everything to the left of -2 and everything to the right of +2. But values between -2 and +2 don't qualify. So if x takes any value in this range, this relation will not be a function. Therefore, since we're asked to find the range of values of x for which the relation is not a function, we simply take values in this range between -2 and 2, with -2 not included, because here we already included -2 and already included +2. So -2 is not included, +2 is not included. So we'll say -2 strictly less than x, strictly less than 2. So this is the range of values of x that will render this relation not to qualify to be a function.